Okay, welcome to Edexcel 8FM0-27, June 2024, question 2. And we've got this question here, a company manages an awards evening. On the table below lists the activities required to set up the room for the evening and their immediately preceding activities. Each activity requires exactly one person. And we're asked to complete this partially completed activity network. So let's give it a go. We're going to know that A, B, C, and D have all been added to the diagram already, so we only need to go from E onwards. And activity E depends on activity C. So C is the immediate preceding activity for E. So I'm going to add E onto my diagram now. So E is going to come out of C just like D does. And it does have to go to a different point than D. They can't both end up in the same place. Let's try adding F. And F has B, D, and E immediately preceding it. So I could connect F to B, I could connect F to D, I could connect F to E. So I'm going to leave F for a while now. And I'm going to add other activities in and then add dummies where I see necessary. So A, B, C, D, and E are finished. I'm going to try and add G. And the immediate preceding activity of G is E. So G needs to come from E. So I'm going to add G now. And I've added G successfully. I now need to add H. And H has a preceding activity of B. So I'm going to draw H coming out of B. And if I do that, H is going to go in this sort of direction. Because I'm nearing the end of my network, so I need everything to converge to a single point at the end. So I've added H. I'm now going to go back to F. And I'm going to know that I've already added activities to H and G. I've already added activities H and G to B and E respectively. So if I tried adding F to B or E, the dummies from the other activities would then mean that H and G are depending on the other activities as well, which would be incorrect. So it makes sense to add F to D. And if we add F to D, we can get F to depend on B and E by drawing dummies from B and from E to the start of F. And this way we avoid H and G depending upon any other activities. And then last but not least, activity J depends upon H, F and G. So activity J is going to come from the end of H, F and G, which means that H, F and G are actually all going to meet at a single point, like this. And finally I'm going to draw activity J coming out of it, finishing at a point. Okay, we've now got another activity network because the company must prepare the meals for the guests. And we've got an activity network for this activity, for this process of activities. And we're asked to show the early and late event times for the activity network in this figure. So we're going to start with an early event time of 0, and we're going to carry out a forwards pass. So to do that, I'm going to go outwards and I'm going to go to events that don't have any other predecessors. So event L and event U satisfy this requirement. However, this event relies on this dummy as well. So the early event time cannot be 9, because for this event to take place, the event at the end of activity L must have also taken place. So when we do a forward pass, we take the largest number of any, we take the largest value of any previous early event time plus the duration of the activity between the last event and this current event. So in this case, with a dummy having an activity duration of 0, the early event time for this event here is going to become 17. So now we're going to continue a forward pass. So continuing along, the activity here, or the event at the end of M, has early event time 35. And the event here has to have a larger of 17 plus 12 or 23 plus 0. And 17 plus 12 is larger at 29. I'm now going to continue this. So the event at the end of activity S has an early event time of 36. The event at the end of activity N has early event time of 46. And now all of the preceding events from this event here have been filled in. So now I can consider the largest potential early event time. So I've got 23 plus 20 is 43. But that's smaller than 36 plus 12, 48. So 48 is currently the largest. 29 plus 15 is 44. So I'm still going to keep 48 in my head. 35 plus 5 is 40. So 48 is still larger. And 46 plus 0 is 46. So 48 is the largest value that we can have, which means this event cannot take place until time 48. Finally, we've got one last event. 46 plus 11 is 57, 48 plus 12 is 60, and 60 is larger. We're now going to perform a backwards pass. So at the very final activity, the late event time is the early event time. And now when we go backwards, we want the smallest value out of the immediate preceding late event time, subtract the activity duration. So let's try that. 60 subtract 12 is 48. And it's really tempting to say 49 for this event here. However, there's also a dummy, so we need to consider this dummy. And dummies essentially are activities with a duration of 0. So now we're going to do 48 subtract 0 is 48, and 60 subtract 11 is 49. Which means that this event up here at the end of N and before X must start by time 48. If it does not start by time 48, the activity down here will be delayed, which will delay the entire project. We're going to continue this process. So the late event time here is going to be 36, because 48 subtract 12 is 36. Let's go down R. 48 subtract 15 is 33. 36 subtract 7 is 29. So if this event does not start by time 29, this event will be delayed. 48 subtract 5 is 43. 48 subtract 11 is 37. So this is going to be 37 here. Let's try this event down at the bottom, because all of the events after it have been filled in. 29 subtract 0 is 29. 48 subtract 20 is 28, so the smallest value is 28. We can do this event between P and Q. 29 subtract 12 is 17. And then finally, we can consider the final event apart from the origin. 17 subtract 0 is 17. 37 subtract 18 is 19. The smallest value is 17. And last but not least, 28 subtract 23 is 5. 17 subtract 9 is 8. But 17 subtract 17 is 0. Question C asks us about the critical activities. So we're going to identify the critical activities now. Critical activities will lie on the path, connecting events with the same early and late event times. So this event here, this event here, this event here, and it's shared in all the events where the early and late event times are the same. So the critical activities are going to lie on that path. But that is not the only requirement. We need to consider the float of each activity. So for example, activity P, although the late event time preceding P is 0, P doesn't have to occur until time 8, and it won't delay the next event. So we've got to consider the float of the activity. And if we consider that, we're going to get a critical path that goes L, and then the dummy, and then Q, and then S, T, and Y. So stating the critical activities are L, Q, S, T, and Y. And this is a very similar thing with the next question. So given the main courses need to be ready to be served at 8 p.m, we need to finish the entire network at 8 p.m. So the start time, right at the beginning, I should have drawn that at the beginning, the start time will be 7 p.m. Across all of the activities take a total time of 60. We need to know the latest time that activity R can start, and activity R is this one here. A common mistake is that a student will write 7:29 because the late event time preceding R is 29 minutes into the network. And 29 minutes after 7 p.m. is 7:29. But actually, R is not a critical activity. So the latest event R can take place is simply it needs to have had its duration of 15 before 7:48 is finished. So I'm going to do 48 subtract 15 is 33. It needs to start at 7:33. Thank you for watching. Goodbye.